Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and today we are going to start from this today onwards for this week the another chapter, metals and non-metals. In the last 2 weeks we have finished the two chapter. First chapter was chemical reactions and equations. Second chapter was acid, bases and salts. The third chapter is metals and non-metals. Okay. To start with, we are going to discuss first of all the physical properties of metals and non-metals. Actually, these are the properties of metals, but we are going to discuss how non-metals are different in that particular aspect in case of each and every property. So, let us see in detail the physical properties of metals. First of all, I will list all the properties and then we will see one by one in detail. So, first property is hardness. Second property is malleability. Second level light down luster. Third property is malleability. Fourth property is ductility. Fifth property is sonority. Next property, sixth property is high density. Seventh property is high melting and boiling points. High melting and boiling points. Eighth property is conductance of heat. And ninth property is conductance of electricity. So these are the 9 properties we are going to discuss in detail in today's session. Let us start. So first property is hardness. So some of the properties which do not require detailed explanation, I will explain them in very brief. So first property, and that is nothing but the hardness. As we know, metals are hard solids. Okay, metals are hard solids, whereas non-metals are usually liquids and gases. Metals are hard solids. Okay, so many examples here we can write down. Okay, like iron, copper, then calcium, then lead, gold, platinum, silver, etc. N number of example we can add here actually. Almost all metals are hard solids, but there is one exception. Okay, there are some exceptions. Some metals are soft solids, which are also called as soft metals. These are nothing but the alkali metals. Some of the alkali metals and some of the alkaline earth metals, they are soft metals. Like alkali metals like sodium, lithium, alkaline earth metals like magnesium, these are the soft metals. Okay, whereas there is one liquid also, that is called as salt. Okay, Okay, liquid metal is nothing but the, yes, you know it, liquid metal is mercury, which is filled in the thermometer, at the bottom in the thermometer bulb. Symbol for mercury is H, capital G small, Hg. Okay, so this is about hardness. Yes, now these are the examples of hard metal, soft metals and liquid metal, but there is exception with the non-metal also. There are some hard non-metals also. Yes, what are the hard non-metal examples? Okay, first example is diamond. As we know, diamond is made up of carbon. And then another example is graphite. Graphite is also made up of carbon. So these are the examples of hard non-metal. Okay. Yes, so this is the first property, hardness. The next property I will write down. Second property, that is luster. Okay, all metals are lustrous with few exceptions. Lustrous metals. Luster means what? They are having a specific kind of shine on their surface, shiny surfaces. Okay, luster, that is shiny surfaces. Yes, so many examples I can write down here, like gold, silver, copper, platinum, etc. N number of examples you can write down here. Whereas there are some non-lustrous metals also, like sodium metal. Okay, sodium metal is non-lustrous. Yes, then there are some examples of lustrous non-metals also. Lustrous non-metal is iodine. Lustrous non-metal example is iodine. Okay. Yes, so this is about luster. Luster, that is a shiny surface. Third property I will write down after luster, and that is malleability. Okay, what is the malleability? Okay, the malleability is the property of metals of getting converted into or beaten into thin sheets. Okay, this property is called as malleability, thin sheets. Okay, yes, so let us see some exceptions, some examples of malleable metals. First of all, malleable metals, so many examples are there. Malleable metals examples are gold, copper, silver, iron, zinc, etc. Okay, then there are certain exceptions again. So let us see some non-malleable metals. So non-malleable metals are soft metals like sodium. As they are soft and brittle, they will not be converted into thin sheets. And mercury, as mercury is a liquid, we will not be able to convert it into thin sheets. Okay, yes, so this is about the malleability. Now let us see the next property, the fourth property, that is called as ductility. Okay, duct stands for tube, right? So this is the property of getting converted into the ducts, that is can be drawn into wires. Okay, yes, so let us see some ductile metals. The metals which show this property are ductile metals. Yes, so here also you can write down so many examples: iron, copper, platinum, gold, silver, etc. etc. Okay, so these are some examples of ductile metal. Now there are certain examples of non-ductile metal as well. Non-ductile metals are sodium, soft metals, sodium, lithium, cesium, gallium, these are also soft metals. And mercury is a liquid, so it cannot be converted to thin wires. Okay, yes, so this is about ductility. Then next property I will write down, fifth property, sonority. Okay, what is the meaning of sonority? The tendency or the property to produce a ringing bell sound. Ringing bell sound on heating a hard surface. On heating the hard surface. Okay, this property is called as sonority. Okay, now let us see some examples. So sonority, metals which show the property of sonority are called as sonorous. So let us see examples of sonorous metals. Okay, so many examples you can write down here: iron, aluminium, copper, gold, silver, etc. Okay, all these metals are nothing but the sonorous metals. Then there are certain exceptions. Let us see what are exceptions. So those which don't show this property are called as non-sonorous. Okay, non-sonorous, again soft metals. The same examples you can write down here also. Soft metals, I have written only one example of sodium, you can add others. Okay, then let us see some examples of some non-metals are sonorous. Sonorous non-metals. Okay, example is graphite. Graphite is made up of carbon. Carbon is a non-metal, right? Okay, so these are the first 5 properties. You can do one thing. First of all, you can take a screenshot of these properties, and then we will discuss the next one, because otherwise it will not be you will not be able to take a screenshot. Now let us see the remaining two properties. Okay, the seventh property is sixth property, not seven. Sixth property is high density. So metals have high density. And seventh property is high melting and boiling point. So for these two properties there is same explanation, so I have written them together. Okay, so why they have high melting and boiling point, let us see. So if you remember, we have seen the states of matter chapter, so in which we have seen the arrangement of constituent particles. We have seen arrangements of constituent particle in solid, liquids and gases. So first of all, let us see. So this is for solids, this is for liquid, this is for gas, right? So we have seen this. In case of solids, the constituent particles are compactly arranged like this. Okay, whereas in case of liquids, there is a little bit difference and irregularity in their arrangements. Whereas in case of gases, they are randomly dispersed like this. Okay, so in case of gases, they are randomly dispersed like this. So due to this constituent arrangement, you can see in case of solid, the particles are compactly fixed in attached to each other. There is little space available there, and the interparticle attraction is also very high. Therefore it is really very difficult to separate these particles from each other. That is the reason the density as well as melting and boiling points are high. Very easy to understand. Yes, the next property we are going to discuss after this. The eighth property is the conductance of heat. 8th and 9th are also the same, so I will explain conductance of heat. Okay, so what is the meaning of conductance of heat? Metals are good conductors of heat. Metals are good conductors of heat. What do I mean by that? For example, if we are making something in kitchen, okay, and to stir, if we use the metal rod, right, or if we use the metal utensil, metal spoon, so if we keep that metal spoon inside the vessel, after some time the handle of that spoon gets hot, right? So why this is happening? Because the heat from the one end of the spoon is getting transferred to the another end. This is called as the conduction of heat, right? So how we can show the conduction of heat? For an example, this is the iron rod. Okay, for an example, this is the iron rod, right? This is the iron rod. Now so this is one end of this rod. I will call this as end A, and I'll call the another end as end B. Okay, these are the two ends of this metal rod. Now I'm going to do one thing. I'm just going to heat the end A. Okay, for an example, I'm just taking the candle, or a burner also you can take. Let us take the burner. Okay, this is the Bunsen burner I have taken. Now I'm just going to heat this end A, right? So what will happen, after some time the particles present at this end A will start heating, so they will become red hot. Slowly this heat is transferred from one end to the another end. So after some time, if I hold it by hand, so if I hold this end, it will become hot, right? If I hold this end, it will become hot, right? So what is this process? This process of transfer of heat from one end to the another end is called as conduction process. Conducting something means transferring something from one end to the another end. So this process is called as conduction of heat, right? Conduction of heat from one end to the another end, right? So this means that metals are good conductors of heat and heat, right? Okay. Yes, now that is the reason we are using the metal utensils for so many purposes, right? Yes, so let us see which are the good conductors of heat. Good conductors. Actually all the metals are good conductors of heat with few exceptions, so I will not write it. So metals are good conductors of heat. Okay, then after this let us see the next part. Yeah, but before that let me just explain this thing to you, why the metals are good conductors of heat. Okay, so as far as the metals are concerned, the if I am talking about only one layer, okay, I'm not talking about other layers, I'm just focusing on only single layer. Okay, so this is the one layer of metal, these are the constant particles. So what will happen if I'm heating it, okay, from one end? So first of all this particle will become red, right? Then this will be transferred to this, to this, to this, to this, by to the end, right? So this is called as conduction of the metal. As the particles in case of metals are very closely arranged, their conduction is also very easy. Okay, then next is the ninth property, I will write down ninth and the last one, and that is nothing but the conductance of electricity. Conductance of electricity, or in another way we can sorry, in another language we can also say conductance of electric current. Okay, yes, so what we can say, metals are good conductors of electricity. Metals are good conductors of electricity. What is the meaning of it? That is, they allow the electric current to pass through them. They allow the electric current or electric current to pass through them. Okay, that is, they are good conductors of electricity, right? Yes, obviously there are exceptions, whereas non-metals, there are exceptions. Okay guys, non-metals are poor or bad conductors of electricity. Poor or bad conductors of electricity, that is, they are also called as insulators. Insulators of electricity, that is, they do not allow the electric current to pass through them, right? Okay, now why this is so? Again the same thing, if I am talking about, for an example, the iron rod. Okay, yes, so if in this iron rod is made up of iron metal, right? Iron atoms. Okay, now these are the metals. Iron rod is nothing but the metals. Okay, yes, so these metals have one tendency. Metals have tendency to lose electron. Okay, metal have tendency to lose electron. That is the property of metal. Usually metals have tendency to lose electron. Okay, yes. So the same thing happens with the iron. Iron also loses electron. Therefore, what happens? Fe is the symbol for iron. Fe has a tendency to lose electron. It loses 2 electrons. Okay, yes. After loss of 2 electrons, as electrons are negatively charged entity, if 1 electron is lost, plus 1 charge. If 2 electrons are lost, plus 2 charge. So there are 2 plus charges on iron, right? So this is nothing but the ion produced from the iron, right? So actually, in case of iron rod, the if I am saying this, like this is the iron rod, it is made up of actually Fe2 plus ions, right? Okay, why? Because metals are having the tendency to donate the electron or give the electron, right? So this is how these Fe2 plus ions will be regularly arranged in the iron rod, right? I have shown the 2 layers for the understanding purpose. Okay, but where these electrons are going? These electrons are not going anywhere in the air, right? They are also there. They are just randomly moving here and there in between the spaces. Okay, they are just randomly moving here and there in between the spaces. For example, like this, like this, like this, like this. So all these electrons will be moving just here and there in between the spaces, right? So this, all these electrons are collectively called as electron pool. pool of electron. Okay, yes, electron pool, or this is also called as sea of electron. Sea of electrons, right? Okay, now this sea of electrons, as electrons are having charge, and therefore they can conduct the electricity very easily. So what happens here, guys? So here, if we are, if this is the electric current, right? If this is the electric current, so as electrons are there, right? Electrons are there means what? Electron is nothing but a bus or car for transport of electric current from one place to the another, right? This is how we can say electrons are nothing but the medium, the car, the vehicle for transport of electric current from one place to the another place, right? So electric current will be carried from electron to electron to electron to the other end, right? Therefore we say that metals are good conductors of electricity, right? Metals are good conductors of electricity. Okay, but there are certain exceptions. Exceptions are everywhere. So let us see the poor conductor metals. Okay, so here the poor conductors, you can just give me a minute, I'll just use a different color. I just use a different color here. Red color I am using for metals since start. Okay, so let us see. Poor conductors of electricity. Okay, metals, examples are tungsten and bismuth and bismuth. These are the examples for the pure conductor of electricity, whereas there is an example of all the non-metals are insulators usually, but there is an example, exception to this. So there is a good conductor non-metal. All non-metals are usually poor conductor, insulators, but there are exceptions. There is exception, and that is nothing but the graphite. Okay, graphite, which is made up of carbon, right? So now in case of graphite, even though it is the non-metal, but still it is a good conductor of electricity. Do you know the pencil cell? If you have ever tried this, we used to try it when we were kids actually. but this is obviously risky. You can do it in the presence of your parents. Once the cell is not working, it's done. What you can do, you can just open that metal coating on it. You can see the carbon rod inside it, the black colored rod inside it, that is made up of many times graphite. Not only for the batteries but for other purposes also, like electrodes, big batteries, they are having the graphite in it because it is the good conductor of electricity. Now, why the graphite is good conductor of electricity? It is also made up of carbon, but it is having carbon to carbon double bond. Okay, two lines in between the carbons is called as double bonds. Okay, yes. Now, out of these two lines, the one line is weaker. Okay, for example, if I say this is orange line, so orange line is weaker bond, and purple line is a stronger bond. We are focusing on weaker bond only. So every line in chemistry contains 2 electrons, right? 2 electrons. Always remember, every single line in chemistry 2 electrons. So these 2 electrons can move freely, right? The 2 electron present in a weaker bond can move freely. Okay, just like I have shown for iron, and hence can conduct electric current or electricity from one end to the another, right? Therefore, graphite, in spite being a non-metal, it is the good conductor of electricity. Okay, yes. So these are the remaining properties. Yes, from 6th onwards, I guess you need to take the screenshot. Yes, take a screenshot first of all for this page. Okay, I hope you have taken a screenshot for this, and then take the screenshot for this page, this another property also. Okay, so that's all for today. So in tomorrow's session we are going to discuss the chemical properties of metals and other things related to it, and yeah, so also the chemical reactions of metals and non-metals. We are going to discuss it in tomorrow's session. I hope today's session was clear to you. Each and every concept is clear to you. If you have any questions related to this, please let me know anytime. Thank you so much for your precious time, guys. Just like for all other sessions, for today's session also, I will be uploading the homework assignment. You can see the teachers portal over here. You have to, your students also will be the same. Go to the resources, then on the left hand side go to the writing material, then to the DPP. Download the DPP. You can see the questions over here. Write down the solutions on a paper or on your notebook. Take a picture and upload that picture on the your portal. Okay, so that's all for today, and thank you so much for your time, guys, and all the very best to you. Take care. Bye.